Hello dear students, my name is Pankaj Sinsinwar and welcome to my channel Maths with Pankaj sir. We are going to start a series of videos in which we are going to solve each and every question of permutation and combination from the past years. So we will be solving around 50 questions. So if you watch my videos before exam, then it will be very beneficial to you. It will be revision for you. So my suggestion for you is whenever question appears on your screen, just pause the video, read the question, understand the question, and then go for the solution, because solution will not take much time and I will not be calculating values. So I will explain you the concept and you will have to calculate it using calculators, because calculators are allowed in your exam. So I will not be doing that. You have to understand the question, I will explain you the concept, rest is on you. So we will start with the first question. Have a look at this. A group of 12 people consists of 3 boys, 4 girls, and 5 adults. In how many ways can a team of 5 people be chosen from the group if exactly one adult is included? It is given that exactly one adult is included. How many adults we have? We have a total of 5 adults. So one adult from 5 adult can be chosen in how many ways? 5C1. We have to make a team of 5 people. So remaining 4 people will be chosen from 3 boys and 4 girls. So into 3 plus 4 is 7. 7C 4. So remaining 4 people will be chosen from boys and girls, which are 7 in number. So it becomes total number of ways becomes 5C1 into 7C4. Let's move to next question or next part. See this part. In how many ways can a team of 5 people be chosen from the group if the team includes at least 2 boys and at least 1 girl? So there are 3 boys, 4 girls, and 7 adults. Let me write 3 boys, 4 girls, and 5 adults. So at least 2 boys must be there and at least 1 girl. So we have 2 boys, at least 1 girl, and we have to choose 5. So 2 adults, 2 plus 2, 4 plus 1, 5. Fine. Now 2 boys, 2 girls, and 1 adult. 2 boys, 3 girls, 0 adults. 3 boys, 2 girls. Okay, take 1 girl first. 3 boys, 1 girl, and 1 adult. 3 boys and 2 girls with 0 adults. Number of ways for the first case can be written as, in this we have to choose 2 boys out of 3, so 3C2. 1 girl out of 4 can be chosen in 4C1 ways, and 2 adults can be chosen out of 5 in 5C2 number of ways. Similarly, others can also be written. I'll write it fast. 3C2, 4C2, and 5C. Four C3, 3C3, now you will add all the number of ways. So for total number of ways, you will add all these, and that will be your final answer. Okay, so now let's move to next question. See, in this part, the same group of 12 people stand in a line. How many different arrangements are there in which 3 boys stand together and an adult is at each end of the line? So if I make the arrangement, on the extreme ends we have 2 adults, and in the middle it is given that 3 boys must stand together, and total number of people in the group is 12. So if 2 adults stand at the extreme end, so we have 10 people in the middle, 10 people, 3 boys and remaining 7 other people. Now these 2 adults at the extreme end, 2 adults at the extreme end can be chosen in 5 C2 ways. These 2 adults at the extreme end can be chosen in 5 C2 ways, but these 2 adults can also interchange. These 2 adults can also interchange the position. So I will not take 5 C2, I will take 5 P2 and 7 people, plus we can consider 3 boys as one object or one person. So if I consider this as one, as they are together, so there are total number of people which is 8. So 8 people are there in the middle. So these can arrange themselves in 8 factorial ways. Also 3 boys can arrange among themselves in 3 factorial ways. So total you can calculate. This is method you have to follow. So let's move to next question. This is question number 2. Find the number of different arrangements of the 8 letters in the word deceived in which all 3 E's are together and the 2 D's are together. So all 3 E's are together, it means there are 3 E's and 2 D's. Remaining we have C, I, V. Total 3 plus 2, 5 plus 3, 8. So total 8 letters are there. Now if these 3 E's are together, I can take them as one entity or one object. So now total number of objects I have, total number of entities I have is 1, 2, 3, 4, 5. So these 5 entities or 5 objects can arrange themselves in 5 factorial ways. So these can arrange themselves in 5 factorial ways. This is my final answer. I'm not going to do 3 factorial and 2 factorial for E and D respectively, because 3 E's are identical and 2 D's are also identical. So that's why I'm not going to multiply this with 3 factorial and 2 factorial. Let's move to next part. See, in this part we have to find the number of different arrangements of the 8 letters in the word deceived in which 3 E's are not all together. So it is not 3 E's are not all together, which means 2 E's can be together, but not, it means 3 E's are not together. 3 E's are not together. But yeah, this question simply means that 2 E's can be together. 2 E's can be together. So let me explain to you. If it was given that none of the E's are together, if it was given none of the e's are together, which means none of the e's are together, then we will have to use spacing method to solve this. If in some question it is given that none of the three objects are together, none of the e's are together, none of the adults are together, and those objects are more than two, so we will be using spacing method for that. But in this question it is given that all the three e's are not all together, which means two e's can be together. So in such case we can do total number of arrangements minus number of arrangements in which those all objects are together, so we can take them as one object or one entity. So yeah, if I have to find total number of total arrangements, then total number of objects 8 factorial, and repeating ones, 3 e's are repeating, so 3 factorial for that, and 2 d's are also repeating, so 2 factorial for d's. Now if I have to find favorable outcomes or arrangements or number of arrangements with 3 e's together, see, if 3 e's are together, I can take them as one object, so 2d and c I v, 3 objects. Total number of, if I take 3 e's as one object, so 1 2 3 4 5 and finally 6, so total number of objects is 6, so I will write 6 factorial divided by, I have 2 d's, so I will take upon 2 factorial. So this is my number of arrangements in which 3 e's are together, and to find the number of arrangements in which 3 e's are not all together, so number of arrangement not all together, simply it becomes total minus together, which is total minus together, which is 6 factorial upon 2 factorial. So students, this is question 81, and our target for today is to reach question number 90. So let's see if we achieve our target or not. So read this question first. In this question there are 6 men and 8 women in the book club, and a committee of 5 has been selected. So total there are 14 people, and Mr. Lane and Mrs. Lane are members of the club. So in how many different ways the committee can be selected if exactly one of Mr. Lane and Mrs. Lane must be on the committee? So case 1, case 2. Case 1 is Mr. Lane is in the committee and Mrs. Lane is not in the committee. Second case is Mrs. Lane is in the committee and Mr. Lane is not in the committee. So this is fixed. Total members in the committee are 5. We have to select 5 members in the committee. In case 1 is already selected. Now we have to select 4 more people. So 4 more people can be selected out of how many people? 12. See, Mr. Lan is already selected and we do not have to select Mrs. Lan. So if we subtract 2 people out of 14 people, 2 people are Mr. and Mrs. Lan. So if we remove 2 people out of 14, we are left with 12. So 4 people can be selected out of 12 people in 12C4 ways. Similarly for Mrs. Lan as well, we have 12C4 ways. So total number of selections, therefore total number of selections equals to, if we add these two, it is 2 into 12C4. You will add and you will get your final answer here. So let's move to next question. In how many different ways can the committee be selected if Mrs. Lan must be on the committee and there must be more women than men on the committee? So it is given that Mrs. Lan is on the committee. So one woman is already in the committee and we have to make sure that number of women in the committee are always more than number of men. So there can be 2 women, further 2 women can be selected and 2 men. See, as Mrs. Lan is already in the committee, so there are in total there are 3 women and 2 men. So number of women are obviously greater than number of men. There can be 3 women and 1 man. Total members in the committee is 5. So last we have 4 women and 0 men. Number of ways for this is see, there were 8 women in total and 6 men. Out of 8 women, Mrs. Lan has already been selected. So we are left with 7 women. Now we have to select 2 women out of 7. So 7C2 into 2 men out of 6, which is 6C2. Similarly for 3 women, 7C3 into 6C3 and this gives us 7C4 into 6C4. Now we will add all these number of ways and we will get our total number of ways in which a committee can be selected where number of women are more than number of men and Mrs. Lan is always in the committee. Final answer. Let's move to the next question. 7C3 into 6C1 and 7C4 into 6C0, which is 1 only. So now we will add these all the arrangements and we will get our final answer. Number of ways in which a committee can be selected where there are more women than men and Mrs. Lan is always in the committee. So let's move to the next question. You can do this calculation by the calculator. So let's move to the next question. A group of 15 friends visit an adventure park. The group consists of 4 families: Mr. and Mrs. Kenny and their 4 children, Mr. and Mrs. Lizo and their 3 children, Mrs. Martin and her child, Mr. and Mrs. Nantis. The group traveled to the park in 3 cars, one containing 6 people, one containing 5 people, and one containing 4 people. So basically, these guys have 3 cars. This is car 1, this is car 2, this is car 3. Car 1 has 6 people, car 2 has 5 people, and car 3 has 4 people. In total, there are 6 plus 5, 11 plus 4, total 15 people. Now, the cars are driven by Mr. Lizo, Mrs. Martin, and Mr. Nantis. So, Mr. Lizo
Let's say this is a driver of the first car, Mrs. Martin. She is in the second car, and Mr. Nentis is driving third car. So one seat is obviously fixed in each of the cars. In how many different ways can the remaining 12 members of the group can be divided between the three cars? So in how many ways we can divide the remaining 12 people? It is very easy. Out of 15 people, 3 are already been seated. So we are left with 12 people. So 6 in the first car, 6 people can be seated, out of which Mr. Lizzo is fixed. So we have to select 5 people. So for the first car, remaining 5 people can be chosen out of the remaining 12 people in 12C 5 ways. For the second car, Mrs. Martin is fixed, so we have 4 vacant seats. So 4 people can be selected out of remaining. If I subtract 5 from 12, I get 7. So remaining 4 people in the second car can be chosen out of 7 remaining people in 7C 4 ways. And in the third car, one seat is fixed for Mr. Nentis, so we are left with 3 seats. So, and also if I subtract 4 from 7, I am left with 3 seats. So 3 people can be selected out of remaining 3 people in 3C 3 ways, which is 1. So my final answer is 12C5 into 7C4. 3C1, 3C3 is 1 only. So this is my final answer. Use your calculator to evaluate this. Let's move to the next question. The group enters the park by walking through a gate one at a time. In how many different orders can the 15 friends go through the gate if Mr. Lizzo goes first and each family stays together? Mr. Lizzo, see, this is important point to note. Mr. Lizzo goes first and each family stays together. So Lizzo family is first. Now we are left with 3 families. Now we are left with 3 family. It is given in the question that Lizzo family has 5 members, 3 children and 2 Mr. and Mrs. Lizzo. Now other one is Kenny. So Kenny family has 6 members, 4 children and 2 Mr. and Mrs. Kenny. Next is Martin. So 2 members in the family. One is Mrs. Martin and her child. And last is Nentis. 2 members in the family, Mr. and Mrs. Nentis. So as Lizzo family is first, so Lizzo's family, if Mr. Lizzo has already entered, Mr. Lizzo has already entered, so there are how many members left? 4 members are left in Lizzo family. So these 4 members can enter through the gate in 4 factorial ways. Now the remaining 3 families can enter the park in 3 factorial ways. For example, K, M, N, Kenny, Martin, and Nentos, or Martin, Kenny, and Nentos, Martin, Kenny, and so on. So how many ways are there? 3 factorial ways in which these 3 family can enter through the gate. So each family can enter. For example, Kenny family can enter in 6 factorial ways, and this Martin family can enter in 2 factorial ways. Nentis family can enter in again 2 factorial ways. So the total number of ways together is 6 factorial into 2 factorial into 2 factorial into 3 factorial. Therefore, total number of ways equals to 4 factorial into 6 factorial into 2 factorial into 2 factorial into 3 factorial. You can calculate the answer using your calci. So now let's get back to the next question. In this park, the group enters a competition which requires a team of 4 adults and 3 children. In how many ways can the team be chosen from the group of 15 so that 3 children are all from different families? Okay, so first we will see how many total number of adults and total number of children we have. Let's get back to the first question. See, Mr. and Mrs. Kenny, Mr. and Mrs. Lizo, Mrs. Martin, and Mr. and Mrs. Nantes. These are adults. So 2 plus 1 3, 3 plus 2 5 plus 2 7. So we have 7 adults and remaining are children. So out of 15, 8 are children. We can count also 4 plus 3 7 plus 1 8. So we have 7 adults in total and 8 children. Let's again go back to our question. So we are having in total we have how many? 8 children and we have 7 adults. Now 4 adults are chosen from 7 adults. So how many ways? 4 ways are there to choose 4 adults out of 7. Now we have to select 3 children, but these 3 children are all from different families. Therefore we have to choose one from each. So again we will see the first question, or part A of this question. See, we have Mr. and Mrs. Kenny and their 4 children. So one children from Kenny family. So one children out of Kenny family can be selected in 4C1 ways. One children out of Miss Lizo family can be selected in as there are total 3 children. So 3C1 ways, and there is only one option for Martin family. So 1C1, which is 1. So again we will go back to our question. Now these 3 children can be selected in 4C1, as we have seen, 3C1 into 1C1, which is 1 only number of ways. This is our final answer. This is total number of ways. So Let's move to next question. Have a look at this question. In how many ways can the team be chosen so that at least one of Mr. Kenny, Mr. Lizo is included? At least one of them is included. So we have three possibilities. Um, Kenny included, but not Lizo. Case 1, Lizo, but not Kenny. Lizo and Kenny both included in the team. So in how many ways can the team be chosen? If Kenny is included and Lizo is not included, then one member has already been chosen. We have to select. We have to select 4 adults and 3 children. So Kenny is already included in adults. We have to select 3 more adults. Total number of adults were 7, and total number of children were 8. So one adult Kenny is already been included, so we are left with 6 adults. We don't have to include Lizo. We are again left with 5 adults. So now we have to select 3 adults out of 5, and we have to choose 3 children out of 8. So this is 8C3. Now Lizo but not Kenny. So Lizo is already included, not Kenny. Again, this is 5C3, and I can select 3 children out of 8 in 8C3 ways. And if Lizo and Kenny both are included, so 2 adults are already there in the team. Now we have to select 2 more adults out of out of 4, not 4. Wait. Okay, so Lizo and Kenny both are included, so we are left with 5 adults. Now we have to select 2 more out of 5. So 5C2 and into, again we have to select 3 children, so 8C3 ways. Adding these all the possibilities will give you your answer. So I hope you have understood the concept behind this. Let's move to next question. So we have 12 marbles and of different size. 8 marbles are red and 4 marbles are blue. Now in how many different selections of 5 marbles? You have to choose 5 marbles only. At least 4 marbles are of same color. So we can say 4 marbles are red and 1 is blue, or all the 5 marbles are red, or you can say 4 marbles are blue and 1 is red. So these are the 3 possibilities which can happen of at least 4 marbles of same color. For this, 4 red marbles can be selected in 8C4 ways, and 1 blue marble can be selected in 4C1 way. 5 red marbles can be selected in 8C5 ways, and 4 blue marbles, which is 4C1, and 4 blue marbles. Okay, I made a mistake. 4 blue marbles are selected, matlab 4C4, all the blue marbles, and one red marble, which is 8C1, one red marble. You will get your answer if you add all these possibilities, all these cases. You will get your final total number of ways or total number of different selections of 5 marbles containing at least 4 marbles of the same color. So let's get back to the next part.
This is question number 7 of permutation and combination. How many different arrangements are there of the 11 letters in the word requirement? So R is repeating 2 times, E 3 times, Q, U, I, M, N, T. So basically 3 plus 3 6, 3 9, 2 11. So how many different arrangements are possible? So total this different arrangements equals to 11 factorial divided by letters which are repeating themselves. So E, there are 3 E's, 3 identical E's. So upon 3 factorial and 2 factorial for 2 R's. Move to the next question. In the same question, if you are asked that how many different arrangements are there of the 11 letters in the word requirement, in which there are exactly 3 letters between the 2 R's. So I will make some arrangement like this: R 1 2 3 and then R. Overall there are 11 letters, so 3 plus 2 5, 6 7 8 9 10 11. So it becomes total of 11 letters. We know R can take how many places? This is R's first place, second, third, fourth, fifth, sixth, and seventh. So R can take 7 places. This RR combination can take 7 places. Now there are exactly 3 letters between the 2 R's. So if you remove 2 R's, then these 3 letters and these 3 plus 3 6, these 6 letters, 6 plus 3 9, these 9 letters can arrange themselves total number of these 9 letters can arrange themselves in 9 factorial upon, as we have 3 E's, so for 3 E's I'll take upon 3 factorial, and this will be multiplied by 7 because RR can be placed at 7 in 7 different ways. So 7 for that. This is total number of arrangement. Let's move to next question. Have a look at this part. 5 of the 11 letters in the word requirement are selected. How many possible selections contain at least 2 E's and at least 1 R? Let me tell you, this question is somewhat similar to when we had to make selections in which we have to select at least 2 boys and at least 1 girl, where we were given like 3 boys, 4 girls and 5 adults. So here also we have to make at least 2 E's and at least 1 R. I will explain to you the basic difference between these two. Fine. So this question is almost similar, but here see, I have to select, if you see, there are 2 R's and 3 E's in requirement, and remaining I will write it as Q, U, I, M, N, T, 3, 6, 9 and 11. So if I have to select at least 2 E's, so 2 E and 1 R, so at least 1 R. Finally I have to select how many? 5 letters. So 2 plus 1, 3 already been selected, so I have to select 2 from the remaining. These are remaining letters. Remaining letters. 3 plus 3, 6. So I will write 2 remaining. Now 2 E's or 2 R's. 1 remaining. So I will write REM because it is similar to R. That's why I'm writing 1 remaining. And now I'll see 3 E's can be there and 1 R. So 1 remaining. 3 E's, 2 R and 0 remaining. Now when there were, see, I have to select 2 E's and I am given how many? 3 E's. I am given 3 E's and I have to select 2 E's, but I will not write 3C2. Unlike I was given 3 boys and I had to select 2 boys, so I wrote 3C2, but here I will not write 3C2. I will not write 3C2. Why? Because 3 E's are identical. 3 E's are identical. So this is the reason why I will not write 3C2. In earlier question there were 3 boys and I had to select at least 2 boys. So I wrote 3C2 because 3 boys were not identical. They were different. So I wrote 3C2. So this is the difference between these two questions, but concept is same. So I will write only 2 remaining. Okay. So for remaining I can select 2 remaining letters out of 6 in 6C 2 ways. I can select 1 in 6C1 ways, 6C1 and finally 6C0. I will add all these and I will get my final total number of selections. So total selections will be addition of all these. Let's move to the next question. See question number 8. A group of 6 people is to be chosen from 4 men and 11 women. So 4 men and 11 women. It is given that exactly 1 man is to be selected and we have to select 6 people. So 1 man out of 4 men, total number of selections we have to find. So 1 man out of 4 men can be selected in 4C1 ways and remaining 5 people can be selected out of 11 women in 11C 5 ways. So this was easy question. Let's move to next question, next part of it. Now read the second part. I have already written. 2 of the 11 women are sisters, Jane and Kate. In how many different ways can a group of 6 be chosen if Jane and Kate cannot both be in the group? So 6 people are chosen out of, let me write, there are 11 women and there are how many men? I think there are 4 men. So group of 6 be chosen and Either Jane is in the group or Kate is in the group, and or neither Jane nor Kate is in the group. So there are three cases. I have written case 1, Jane is in the group. Case 2, let me write, Kate in the group, and third one is Jane, neither Jane nor Kate, neither nor Kate. Now we will see total number of selections. So if Jane is already in the group, now we have to select 5 more people, and 5 people can be chosen out of see, there are in total, there are how many? 11 plus 4 equals to 15. So if Jane is already selected, there are 14 remaining people, out of which we do not have to select Kate. So remaining people is 15 minus 2, Jane and Kate. So remaining people are 13. So I can write 13C5. So I have to select 5 more people in the group. So 13C5. Same for the Kate, 13C5. And neither Jane nor Kate is in the group. So I have to select 6 more people, like 6 people of the group from remaining 13 people. So this is 13C6. So if I add all these possibilities, I will get total number of selections. Total number of selections equals to summation of all these 13C5, 13C5 and 13C6. Let's move to the next question. Okay, now read this ninth question. The 26 members of local sports club include Mr. and Mrs. Khan and their son Abad, whatever. The club is holding a party to celebrate Abad's birthday, but there is only room for 20 people to attend. In how many ways can the 20 people be chosen from the 26 members of the club, given that Mr. and Mrs. Khan and Abad must be included? So, fine. So there is only a space for only 20 people to attend. So space is just for 20 people, and there must be Mr., Mrs. Khan and Abad. So 3 people must be there too. 3 persons are fixed. So now we have to select 17 more people for the birthday party. Out of, see, there are 26 members of the local sports club, 26 members, in which Mr. Mrs. Khan and Abad are also included. So excluding Mr. Mrs. Khan and their son, so we have 26 minus 3, which is 23 members, excluding Mr. Mrs. Khan and their son. So now we have to select 17 more people for the party out of 23. So answer to this question is 23C17, because 17 other people can be selected out of 23 in 23C17 ways. Next question. Read question number 10. Richard has 3 blue candles, 2 red candles, 6 green candles. The candles are identical apart from their colors. He arranges the 11 candles in a line. Find the number of different arrangements of the 11 candles if there is a red candle at each end. So let me make the arrangement. Red candles are at each end. So in the middle, I have how many? 3 blue candles and 6 green candles. These blue candles are identical, and green candles are identical to each other. So if I ask you, see, red candles are fixed. They cannot even interchange because they are identical. So now I can arrange the remaining nine candles, 6 plus 3, 9 candles in the middle in how many ways? So total arrangement of 9 candles in the middle will be 9 factorial divided by, because 3 blue are identical, so 3 factorial, and 6 green candles are identical to each other, 6 factorial. This is our final answer. This question is interesting. Its second part is really interesting, and let's move to the second part. So this is part B, in which the question is asking, find the number of different arrangements of the 11 candles if all the blue candles are together and red candles are not together. So it is given blue candles are together and red candles are not together. So if I write a statement, and it is very much important, blue candles together, it gives us two possibilities: blue candles together and red candles together, plus blue candles together and red candles not together. This question will be solved like this. Let me explain again. Blue candles together. So if blue candles are together, so there are two options for the red candles. Either red candles will be together or red candles will not be together. So this is the number of arrangements that we have to find. Blue candles together but red candles not together. So we will make this subject. Blue candles together and red candles not together equals to number of arrangements of blue candles together minus blue candles together and red candles together. We cannot directly find number of arrangements for red candles not together. So for blue candles together, how many? Let me first give you write the given data. It is given that there are 3 blue candles, 2 red candles and 6 green candles. So if blue candles are together, so we will take it as one object, and if we take 3 blue candles as one object, so we are left with 6 green plus 2 red, which is 8, and 3 blue are taken as one object, so 8 plus 1 9. 9 factorial divided by 2 reds are identical, so 2 factorial for red and 6 factorial for green. I have not taken 3 factorial for blue candles because I have taken them as one entity or one object. Now minus blue candles together and red candles also together, so I will take red candles also as one entity or one object. So now total number of objects are 6 plus 1 7 plus 1 8. So this becomes 8 factorial divided by 6 green candles. 6 factorial for green candles. I have not taken 2 factorial for red and 3 factorial for blue because I have already taken them as one object respectively. So this is my final answer. This question was really interesting, so it might repeat in your exam, so be careful. Let's move to the next question. Read 11th question. In a music competition, there are 8 pianists, 4 guitarists, 6 violinists. So 7 of these musicians will be selected to go to the final. So how many different selections of 7 finalists can be made if there must be at least 2 pianists, at least 1 guitarist, and more violinist than guitarist? This question is similar to boys, girls, and adults, but here we have one more twist: more violinist than guitarist. So we have to consider this point as well. So let me write 8 there are pianists, 4 there are guitarists, and 6 violinists. At least 2 pianists are there, so 2p. At least 1 guitarist is there, so 1g. Total I have to select how many people? 7 musicians. So remaining will be violinists only. So 2 plus 1 3. So remaining 4 people will be violinist. So 4 violinist, and condition is more violinist than guitarist. So 4 violinist, 1 guitarist. So obviously this is what do you say, valid combination. Now 2 pianist, 2 guitarist, and 3 violinist. Again 3 is greater than 2, so it is also valid. But we cannot take 1 guitarist and 3 guitarist and 2 violinist, because violinist must be greater than guitarist. Now I will choose 3 pianist and 1 guitarist. 3 plus 1 4, and 3 violinist. 3 pianist, 2 guitarist, and 3 plus 2 5 plus 2 more violinist na. So this will not be valid because 2 violinist, so violinist and guitarist will be equal, so this is not a valid combination. So I have to erase this. I think now I will go for 4 pianist. 4 pianist. So I have 1 guitarist, 4 plus 1 5, and 2 violinist. So I think there are 4 possibilities only. So now I will write combinations for all these. Eight C2, 2 pianist out of 8, into 4 C1 and 6 C4. For this again 8 C2, 4 C2 and 6 C3. Now 8 C3, 4 C1, 6 C3, 8 C4, 4 C1 and 6 C2. So we will add these all, and that will be our final total number of selections, which will give us total number of selection. This is our total selections. Let's move to the next question. Read question number 12. This is very easy. Find the number of different ways in which 10 letters of the word summertime can be arranged so that there is an E at the beginning and an E at the end. So let me write the repeating letters. M, M, and M. M is repeating 3 times. E is repeating 2 times, and summer is unique. U, E, R, R, T, I. Okay, so 3 plus 2 5, and 5 plus 5 10. So total letters कितने हो गए? Total letters is 10. It is given that E is at the beginning and E is at the end, so positions are fixed. So 3M and SURTI can arrange themselves in the center or in the middle in how many ways? So total number of letters in the middle is 10 minus 2, which is 8. So total number of arrangements, total arrangements will be 8 factorials excluding 2 e's at the extreme ends upon 3 m's are 3m are identical, therefore 3 factorial. So this was easy. Let's move to the second part, which is interesting. Read part B. Find number of different ways in which 10 letters of the word summertime can be arranged so that the e's are not together. E's are not together. So how many e's were there? 2 and 3m. SURTI. So e's are not together. Fine. As there are only 2 e's, so we can solve this by total minus together. But if there were more than 2 e's, for example, if it was given that none of the m is together, so uh, if it was given, then we would have to solve it by spacing method. But for now it is easy. We will simply follow total minus together concept. Total minus together. So tell me, total number of arrangements of the word is 10 factorial divided by 2 factorial into 3 factorial minus together. It means 3 e's are together, so I can take 2 e's are together, so I can take 2 e's as one object. So how many letters do I have right now? 1 2 3 4 5 6 7 8 and 9. So 9 factorial divided by 3m, because m are identical, so 3 factorial for m. I have not taken 2 factorial for e's because I have taken e's as one object. So 9 factorial upon 3 factorial. This is my final answer. Read part C. Again we have 10 letters, 3m, 2e, and SURTI. So it is given that 4 letters are chosen. 4 letters are chosen. It must contain at least one M and exactly one E. So at least one M, exactly one E,
So 2 remaining letters are SURTI. So 5 letters are remaining. 5 letters are remaining. I am considering them as remaining. So 2 remaining letters, total becomes 4. Now 2M and 1E, because there is exactly 1E always. So 2 plus 1 3, and 3 1 remaining, and 3M again 1E, so 0 remaining. We have already solved this type of problem earlier, and I will not take 3C1, 3C2, 3C3 in M and E. 2C1 I will not take, because M and E are identical, so that will not make any impact. So I will consider only remaining. So we always consider remaining letters only in case of alphabets. So I will consider remaining only. So I can select 2 remaining out of 5 in 5C 2 ways, here 5C 1 ways, and here 5C 0 ways. I will add them, and that will be my final answer. Total number of selection. This is my total selections. This is my total selection. So this is done for today. I hope you understood that what kind of questions are being asked in the previous years, and now you can prepare yourself uh, accordingly, and we will continue the same in the next lectures as well. uh, so मिलते हैं नेक्स्ट वीडियो में. थैंक यू सो मच.